Hello, welcome to first episode of the Java Game Development Platformer series. I've noticed that there are many Let's Play series you can watch on YouTube. However, I have not seen many Let's Make a Game series available. And this video series is supposed to fill that gap. The goal of this series is to show how easy it is to write a game from scratch using available tools and libraries, and I will show and explain all the programming required so you will not miss anything. Any code developed here is open source and can be used in any way, shape or form you wish, provided you give me some credit in your projects. I am not an artist and I do not aspire to be one. In fact, I'm pretty horrible whenever I try. So most of the graphics you will see in the game will be just placeholders, as this series will focus mostly on developing the game engine and not providing a polished gameplay. Prerequisite for you to be able to follow this series is some knowledge of Java and a very basic understanding of 3D graphics. And by basic understanding of 3D graphics, I mean that you have to understand some geometry and have a spatial sense. I will try to either explain everything else or point you to web pages where you might read on any things that I will be using. In this series, I will use a couple of free libraries. First of all, I will use libGDX, which is a cross-platform open source library for a 3D game development written completely in Java, and under the hood, the library uses OpenGL. I will also use an entity component system, which is a great tool for game development, especially if you want to be able to keep adding new features to your game. As you will see during this series, that's how I'll be working on it. And it also allows building up the game in small incremental steps, and in some more advanced setups allows for creating mods for games, which is something I'm really excited about, and I've seen some awesome uses of that. Since I was never able to find an ECS, which is a short for Entity Component System, I would be satisfied with, I wrote my own, which is of course open source and available for download. Lastly, to glue all the pieces of code together, I will be using a context system. The goal of the context system is to allow initializing and building an application from smaller parts that don't necessarily have to know much about each other. If you, for example, have ever worked with Spring Framework, you might be familiar with the concept where you just write a couple of classes and then provides a couple of setters, and then using an XML file, you basically say this class should be working with this class should be working with this class, and so on. And then when you start the application, Spring basically creates all those classes, instantiates them, glues puts all the classes together, and voila, you have your application running. And once again, I was not able to find a library that I was happy with. I was considering using Spring, but it's a huge beast and doesn't really work great if you want to put a couple of megabytes into your application just to be able to instantiate a couple of classes. So I wrote my own context system, and it's also open source and available for download. The links will be in the description of the video. Finally, in this introduction, I'd like to give a few shout-outs. First and foremost to the Terasology community, Terasology is an open source sandbox game, and I'd like to thank them for inspiring me to create this series and for teaching me more than a few things about game development. Secondly, shout out to Thin Matrix on YouTube for providing amazing content on game development in Java. This YouTuber taught me a couple of tricks in OpenGL in the videos, and gave me also a better understanding of the OpenGL library. Finally, a shout out to T-Machine for providing amazing content on ECSs, so Entity Content Systems. And the blog he has is invaluable if you wish to learn about it. He's a huge evangelist of the approach for game development and also for some other uses. Yeah, that's it for shoutouts. Now a little bit about my setup here. During this series, I'll be using IntelliJ IDEA for the development. This is the Ultimate Edition. The reason why I'm using it is because this is the IDE I'm most used to, and I've been using it for many years throughout all the versions it has been going through. You, however, can use whichever IDE you want, you wish, as long as you'll be able to integrate with the project somehow. If you just wish to follow with me writing your own code, maybe playing around with the stuff I provide here. For building the project, I'll be using Gradle. The reason for it, I don't really like Gradle myself, but I don't want to go into that. The reason why I'm using Gradle is because that's what the libGDX projects gets created with. So whenever you create a new project with libGDX, you have Gradle. So coming to libGDX and creation of the project, if you create a new project, this is what you, after opening in your IDE, this is what you will most likely see. I have already integrated into the project the context and ECS, so we have the entity and context library that I wrote. I've added them to the build Gradle as dependencies. And I also added a gaming module here. This module contains some common classes that I was able to extract from another game I was working on. These classes I think are very easily and readily reusable for any other game development, which is why I put them here. I will be using them extensively. They are open source. You can use them, play with them, add new one, change them, whatever you wish. And currently the code for this module resides in this project. However, at a later point, I might extract to a separate library, similarly to the context and entities libraries. So the libGDX creates a core module for you, and also one module per each deployment platform you wish to use. In this project, I just created the desktop one because I didn't want to go through all the hell required to integrate the Android and iOS libraries needed for me to be able to open the stuff in IntelliJ. So in here, I just have desktop one, but you can do whatever you wish. You can add the other Android and whatever deployments you wish. But just know that libGDX creates a one module per environment you wish to deploy to. In this case, this is desktop, which is basically Windows, Mac, or whatever you have, Linux. In this project, the desktop project, you just have a launcher that is specific for this platform. This launcher just creates a configuration that you can modify here. I'll be doing this later on. And also creates the application passing the core class that is created for you here. This core class is almost empty. It doesn't do anything. This is where you will be adding all your stuff that's going to be common for all the platforms. Okay, so let's talk about this platformer class that was created for me. And so as you can see, there's a couple of methods. The create method. The create method is called once when your application is first started. And then you have a render method, which is called all the time. It's called basically whenever the applications wants to refresh the screen of your either desktop machine or your Android or iOS device or anything else. So this is where all the game code is going to be happening. We have a resize method, which basically is called whenever the screen is resized, be it on desktop or when you rotate your Android device or iOS device. You'll have this method called with a new width and height of the window. And finally, we have this pause method, which is called when the application is being closed. So this is pretty basic. Let's do something with it. So the very useful thing that libGDX provides is an FPS logger. This is very good way to track if you are introducing any lag, if the code that you just added adds any lag to the whole application. And the way we can do it is just create an FPS logger here, a field first. We will create it in the create methods. to initialize it, new FPS logger, and then in the render loop, we will just call it to log. Okay, let's launch the application. Unfortunately, I'm working on two screens. The screen that you see is my secondary screen, not my main screen. Therefore, whenever I run the application, it opens the window on the other one. I have to drag it through to this window. Okay, so now in here we see output, and it's reporting about 60 frames per second, which is, well, for a black screen, you would expect a bit more. The reason why we see only 60 FPS is because of this config. By default, the default config that's provided you has a limitation on number of frames, and which is actually fair to use it for normal deployment of application where you'll be sending it to your customers or to showing to your friends, because you don't want your application to take 100 CPU and get their graphic cards on fire or high temperatures. Therefore, it's limiting to 60 FPS because human eye will not be able to see any better than that anyway. However, for our testing purposes, when we want to see the difference between us introducing some code that renders something or does something, some game logic, whether we want to see that is there a problem with the performance of it, we have to remove this limitation. And please note that this is only for debug purposes. Remove for production. We will be setting the background FPS to 0, which means unlimited in this case, and foreground FPS to 0 as well. So let's run it now. And, well, I'll give you a hint now. That's not enough. We will still be seeing 60 FPS. The reason for it is that by default, there's something which is called vsync. It's enabled. What this means is that the application that you'll be running, the render method, is going to be called at most as many times as your monitor refresh rate is. So my monitor refresh rate, the simulated refresh rate, is 60 FPS. I'm using LCD, so it's not an actual refresh rate, but that's how it's saying it is. So in order to remove this limitation on this code, so to have this render method called as often as possible, we have to also not only turn off the limitation on FPS, but also turn off the vertical sync of your monitor. So now let's run the application again. And now you will see some insane numbers. Okay, the application is getting better. Yeah, we're seeing around 11,000 frames per second, which is, for a black screen, I guess, great. As we'll be adding new stuff to the code, it will probably be getting much, much worse than this. Okay, I think that's good enough for a first episode. I hope you'll check out my other episodes for this series, and thanks for watching. Bye.